Morning. Good morning.
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 I'm gonna run through 9 today.
I just realized
Would you
that
read?
when I posted that video of my lab, I didn't have the power circuit all the way hooked up. Yeah, that's a good thing.
I haven't seen it yet.
Good.
That's good.
I'll just take it off there real quick.
So if you missed yesterday, you want to take a look at the video and the rundown of timers and on delay, off delay, all that good stuff. This is lab 9. The first thing that I'm going to do is show you how I'm going to get my proto board set up, because we need all 3 ice cube relays. We need the little bitty one and the 2 that are mounted to the right of your trainer. And I want to show you how I'm setting mine up, because I'm going to tell you on here what row I'm landing a wire on. So if you go through this and you have difficulties, or if you can't follow as fast as I'm working, then you can go back through the video to see what I did. But we need 3. Oh, by the way, we got this timer going again.
Yep. The time is 9:53 that it will go off.
Again?
Yeah, I thought that's what you said.
Are we gonna bet again?
I don't know about that. I think I'm gonna quit while I'm ahead.
You gonna lose your homework assignment? All right. So yeah, it was pretty close. If you weren't here yesterday, what was it, like a minute off?
2 minutes early.
It wasn't bad for a 1-day timer, but we ran it again just for kicks. All right. So 2, 3 push buttons. Do go to the very top, so I'll stab into D1 and D3. I'll stab into D6 and 8. And I'll stab into D11 and 13. And then on the right side, all the stab-ins will go into row G, or column G. And then what else? Oh, the control relay. I'm going to put this all the way at the bottom with the coil being on the top. So if I put this in here, spanning that rail, I got in column E, the coil is going into 20. Normally closed is 26, common is 28, and normally open is 30. So that is how I'm going to have mine hooked up. And then I'm going to put it,
Excuse me.
I'll go, so We got 2 start buttons, so I'll go green. Go green, green, yellow. All right, and then keep in mind I've got a resistor jumping from the coil on this side. So from row 20 up to row 16. So that row 16 is going to be where I lead into the coil with this, and all that is a voltage divider to go from 24 to 12 volt. Making sense so far?
Yeah.
All right, so I need to look at my power circuit first because we're no longer doing forward and reverse. So I need to go, let's see. I'm going to use, I'm going to use one of the bigger icebergs for MS1. Yep. Why do you think I want to do that?
I have no idea.
Because I want to use different color wire for the power circuit.
Yeah.
So for you guys, I would recommend using some of the bigger stranded wire.
That is not what I did, but mine works. So.
And Garrett, I know that you started this yesterday and you used the little guy for MS1, didn't you?
Yep.
That's fine. I don't care how you do it, but
Gotcha.
I'm always right and you're always wrong. So redo it.
Ben, are you sure about that?
Is this the same lab you guys were doing yesterday?
I'm totally kidding. And it was 9:43 yesterday, by the way.
Do you want to lose a second time?
I'm kidding. I'm kidding. I thought I was wrong once, but I was mistaken.
Okay.
See what I did there?
Mm-hmm.
You guys are too tired to listen to my tomfoolery, aren't you?
Mm.
All right.
Not terrible.
All right. So power circuit first from fuse 4 to MS1 normally open. So I'm gonna call my right one as MS1. Okay, just so everybody knows.
Gotcha. I took pieces of tape and taped them and then wrote on the tape.
I gotta undo a lot of this stuff. All right, that's more better. All right, so I need to go from plus 24 to a normally open in my MS1. So normally open, I'm going to use, what is it, 9 and 5. So here's a plus 24, and I'm using blue for my control wire, or my power circuit. I'm going to go straight over to 9. Then the other side of the normally open, so I'm going to mark that off on my print. The other side of the normally open, I have to go through my fake overloads into M1 plus. So pin 5. To motor positive. So that's done. And then the negative side of my motor is just going straight back to negative on the power supply. All right, so I can mark that off. All right, now I need a number 1 to my stop. I'm going to use yellow for all my control wiring. My number 1 over to my stop. I need a 3 over to one of my starts, down to another start, and then down to CR1 normally open. So I'm gonna use CR1 is gonna be the little relay down here.
Okay.
And before I keep going here with the number 3, let's look at this ladder and see what it does. So this top part that I'm circling, we'll consider that like a control on circuit. And you got 2 start push buttons, and any start should be wired in parallel, right? Any stop should be wired in series. So even though those 2 are really close together on the print, those could be like all the way across the building, right? Just keep that in mind. But if this is control on, none of this stuff down here is going to work unless control relay 1 is energized, right? This green light turns on. So that's control on. You can turn the control on from either of these 2 locations, start 1 or start 2. The bottom part is what starts the timing process. So CR2 energizes and holds power for TR1 to do its thing. So start 3, which will be the yellow push button, once that's pressed, it allows this little timing process to start. So once LS1 closes, it energizes the coil of this guy and it starts timing. At that point, since TR1 normally closed down here, whoops, that's normally closed, so this is an on delay. Which means that it's not going to change state until the timing process is done. Okay. So there's a 10-second timer. When the limit switch is closed, this red light will stay on for 10 seconds. And then after 10 seconds, it will turn off and MS1 will turn on. Does that make sense? If you're confused about normally open, normally closed, on delay, off delay, take a look at the video from yesterday. It should be up online already. Any questions on how that process is supposed to run?
Nope.
All right. So I need a wire number 3 from the other side of my stop down to PB1. Push button 1. So I'm going to put it on the top button in row 1. That's wire number 3. I need to jumper that down to the top of the second green push button. So my little jumper wire here is going from row 1 to row 6. So basically the top of the first start and the top of the second start. I'm going to turn the lights off here so hopefully you can see the board a little bit better. You see the board a little bit better now, right?
Yep.
Then I need to take a number wire number 3. So far I've done stop down to the start down to this start. I need a wire number 3 down to normally open CR1. I'm gonna put another little jumper wire from row 6 down to row 30, all the way down at the bottom. And that completes my wire number 3s. So what I'm going to do now is I'm going to work on these wire number 4s, but I'm going to stop after I get to this point, and I'm just going to check my control circuit, make sure these are getting energized. So from the other side of my start, or basically the bottom of the top green button, I need to put a wire number 4 jumper down to the bottom of the second green button. So I'm going row number 3 to row number 8. And then I'm going to go row number 8 down to this side of the normally open. So I'm going to go to the common then. So I'm going to put a little jumper from row number 8 down to row number 28. So that's this. I need a wire number 4 to control relay 1 coil. And actually that's going to be the resistor. I should have put a resistor on here, right in there. So I'm going to go row number 8 to row number 16, which is my resistor. So that puts this one done, and then I just need to get up to the green light. I've already got a tail coming off of my green light, the terminal strip. I'm just going to grab that sucker, take him down to any spot that I've got a wire number 4. So I'm just going to go to row 16 because it's nice and open. So this is done. Now everything above this, I'll make it a different color, but everything above this blue line is done. Except for, do I have both of my negatives? So 2 wires. The other side of the green light is already done. The other side of the control relay I have a little jumper from row 20 on the right side of this. So the other side of the coil over to this negative rail. And I have that whole rail tied into power supply negative. So that's already done. You might, if you haven't done that, you're going to have to run from row 20 on the right side up to here. So just to mark those off on my print though. At this point, I should be able to start CR1, which is this, and turn the green light on with either of these two green push buttons. So I'm going to back out. You can see the pilot lights, and I'll test it out.
Are both green push buttons? I'm trying to see how you got them tied in. You got one tied into the top, one tied into the bottom, like the bottom of one tied into the top of the other. Am I looking at that correctly?
We have to follow the print and follow the wire numbers, but I can zoom back in.
Well, no, I'm just looking at how you got the two green buttons, push buttons tied in.
Tied in, like wired together, or on?
Yeah, wired together, like on the.
Okay, so I got wire number 3 going to the top of this button.
Right.
Going down to the top of this button.
Oh, it's at the top?
That's wire number 3.
Okay, I see that. I see.
And if you get lost on any of this, just go back. You can always go back through the video that I post, because I'm telling you exactly where I'm putting every single one of these wires.
Yeah, I see it.
And then the bottom of this goes to the bottom of the next button, and that's wire number 4.
Right, I see it now.
All right, so
All right.
I'm gonna test this. So either one of these should, but does not. The relay's clicking, but my green light's not working. Why is that? Oh, it's not tightened. All right, now it should work. Try the bottom button. All right. So I'm good to move on to the bottom part. I'm going to zoom in real quick and show you something that's wrong on this print. This wire number 5, is that right?
No, it should be 4.
Should be 4. So what I did with this is there used to be another stop push button right here. But I took it off because we only have one stop on this trainer. And then I forgot to change all the wire numbers.
Oh, I see. So when they drew it, they drew the main as a E stop, and then that one's kind of the one between 4 and 5 would be a function stop, right?
Yeah, like timer stop.
Yeah. Because you don't want to have to reset the machine every time you want to stop it.
Right. that should be better. So 4, 5, okay. All right, so now I need to pick up any wire number 4 and jump her to the top of the yellow push button. So I just need a small jumper wire here. And wire number 4, I'm going to go from row 16 to row 11. That does, whoops. That does that. And then I need a 4 going to CR2. Which is going to be my left ice cube relay. Normally open. So I'm going to go from the green light, because this is a number 4. So I'm going to tie into this terminal strip right here and go over to pin number 5 on the ice cube relay. Mark that off on my print. Wire number 4s are done. So wire number 5s then are start 3. So the bottom of my yellow push button to CR2 coil, which is here. But I've also got to hit the yellow light, right? So I'm going to go from the bottom of the yellow push button, row 13, up to the yellow light, and also from the yellow light over to CR2 coil, right here, pin number 13. So from yellow light down to the bottom of the yellow push button, which is row 13. So I got that and that done. And now I'm going to go from the yellow light up to CR2's coil. yellow light up to pin 13. You guys ever throw a wire underneath there and then tighten it up and then the wire falls out because it didn't get inside the lug?
Yeah, it's a pain in the ass.
Isn't that fun?
Yeah.
It brightens your day, doesn't it?
Mhm.
All right, so I went from yellow light up to the coil of CR2 and check these twos. So pin 14 on CR2, which is right here. I've already got that. Where's that jumper from there to this 14? So I need to take this back to the terminal, the negative on terminal strip. So that's done. Yellow light is done. Now all I have to do is tie in this wire number 5. And then I can test that little control circuit. So I'm going to go from the coil of CR2, pin 13, to the other normally open side of that same relay. So pin 13, jumper wire up to, I think this is 5. Yeah, 5. All right. Now I've got that tied in. I can test this little control circuit. So can I push the yellow button right now, which is this one, and have CR2 energize and have the yellow light energize?
Not unless you have the initial start button sealed in.
Right, because wire number 4, which is right here, does not have plus 24 on it, right? This entire, let me go to blue. This entire wire number 4, all of this is dead, right? But if I press either of these two start push buttons, it will energize wire number 4, enabling this bottom process, right?
Correct.
So like Nick just said, if I want to test the yellow button in CR2, I need to press the green one first. Okay, so now wire number 4 is energized, the green light turned on. If I press the yellow one now, I should get CR2, which is this one, to energize and have the yellow light turn on. Making sense?
Correct.
There you go.
Nice.
And then the stop button will disable all of it. So I have to go green, yellow, and then run the timing process. And now we're ready to move on to the timing process. So that's this stuff down here. So the first thing I need to do is pick a limit switch. I'm going to use the top one. And I need to tie into wire number 5, which could be anything that I just did. So I think what I'm going to do is come out of here, since there's only one wire there, and come down to the limit switch, normally open, which I believe is these two screws, right?
So you're going to the limit switch 3 and 4, right? Contacts are the screw numbers.
Yep.
Okay.
Yep, it actually says normally open on there. You can also see, just by actuating the switch, that plunger moves from left to right when you push this down.
Okay.
But these two pins are normally open.
Okay.
So I got my wire number 5 to there. You know, wire number 5 to TR1 normally open. Here's TR1. Normally open. Look at this one.
$25 and 28.
Yeah. So I'm going to go to I'm going to go to 25.
Okay.
That's the common. So watch what happens now. Since TR1, I've got, let me show you this diagram. It looks like this. 25, 28, 26, and 28. So if I take this wire number 5 to 25, that's the common, right? So it looks like we've got it drawn like this. By the way, the timer on my workshop just
Went off.
changed state. 9:51.
Oh.
Pretty darn good, Garrett. Pretty darn good. So if I go to 25 with my common, I don't need to do this one, right? Because I've already got that common wired up. I guess what I'm saying is this is on the same potential as this. I could use both timers, but I'm really controlling a normally open and a normally closed with one timer, right?
One set, right?
Right. So I only have to take a wire number 5 to pin number 25 on the timer. And where's the best place to do that? Probably go from the limit switch over to pin number 25. Pin number 25 over to the other normally open. Limit switch. And then that takes care of this and this. And if that doesn't make sense to you, how we just covered 2 terminals with 1 wire, let me know and I'll go back over it. Except I landed that on the wrong side of the limit switch. I need to tie into wire number 5 with that. Follow?
Yes. So you got to land it on the same screw, whether it's on the limit switch, whether it's 3 or 4, they both need to be under the same one.
Correct. Because
There.
it has to be on the same potential as all the other wire number 5s, right?
Yeah.
Almost screwed that one up.
You had the potential of doing something wrong there.
All right, so the other side of the limit switch, then wire number 6, I need to go from the other side up to the coil of TR1, which the coil on this is pin A1, right? Right.
Yes. So looking at this schematic, the way you have it, you have to hold the limit switch closed for the timer to make a full cycle, right?
Yep.
Okay. So real world application, that's energizing the motor off of the timer until it moves a certain distance and comes off the limit switch, and then it'll power itself off.
Yeah.
Okay.
Yeah.
Okay.
So it's a wash tank. Part goes up, hits the limit switch, the motor runs the pump.
All right. Red light. Yeah.
After something, and then I don't know.
After 10 seconds, red light goes off, and it shows you that it's okay to open the tank.
Yeah, I like it.
Yeah, that's got real applications.
I like it. All right, so what I just did there was wire number 6 on the other side of the limit switch to the coil. Wire number 7, so normally open, is going to be pin 28 on the timer to MS1 coil, which is here.
Okay.
28 over to 13. That takes care of wire number 7. Wire number 8 is going to be the normally closed, so pin 26 on the timer over to the red light.
Yep. Small jump.
I've already got a tail on the red light. I'm just going to shorten it and go up to 26. So that takes care of those two. Now I need to check all these twos. So I need a negative from TR1. So that's going to be A2 on the timer over to the negative of the terminal strip.
And the only way that that would change is if you were powering the timer off of something else.
What do you mean?
You would want it powered almost all the time, right?
No.
No.
Because as soon as you put 24 volts on this thing, it starts timing.
Okay.
You know what I mean?
Yeah, I got you now. I'm used to the other timers I've seen before. They have multiple timer blocks that sit in a rack,
Right.
and you power the rack, and then the individual timers have, depending on what you're doing.
Yeah.
Okay.
So I just did that. Where'd you go? MS1. That is this. The negative is already tied in on mine.
Okay.
So that's done.
And your red's already tied in.
And the red light is already tied in too. So I'm ready to roll. The only thing I need to do is check the timer for 10 seconds. So 25, 26, and 8 are associated with, is that T1 or T2?
Should be T1.
It's T2 actually.
Is it really?
Yep.
That's different because on the side, the way they have it set up.
You know that part that we were looking at yesterday that shows S
Yeah.
with the gray bars? If you look at 25, 26, and 28, or 25 through 28, it says T2.
Does it? Oh, yes. Yes, it does. It's
So
T2.
T2 is down at the bottom. I need to go put that for 10 seconds times 100%. And we're ready to rock.
Oh, yeah, because I was reading it top to bottom because the way they have the contact schematic set up on the side, because it's higher, you would think it was T1. That was my mistake. I thought it was T1 because it's higher up reading it.
Yeah, I see what you're saying. Check this bad boy out. So I can hit any one of the green buttons to start the process. Green light turns on. The yellow button will enable the timing process. You see the red light came on instantaneously because it's on a normally closed rung, normally closed contact TR1.
Correct.
For the timing to start, and on your timer, you'll see that UN means that the timer is enabled. It has voltage. And R, the red light, is going to show you 1 second blinks. So you can actually use that to count to 10. But in order to enable this, I have to close the limit switch first, right? So I'm going to hold this down. We'll count to 10. After 10 seconds, you should see the red light turn off and the motor turn on. If you don't understand why, then let me know and we can walk through it. But we'll count to 10 here. You ready?
Yep.
1,001, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty cool, huh?
Yep.
Do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's your lab, folks.
All right.
That's all.
That's all you have to do.
Awesome.
Are
Do
you
you have
gonna?
any-
Are you redoing yours, Garrett?
No, I did read it yesterday while you were going over the other timers.
Okay, cool.
It's all done and it works. The motor turns on how it's supposed to.
Sweet.
I posted that video of the new version, the one that actually turns the motor on.
Sweet.
So
Appreciate you guys sticking around.
no problem. I had a question for you real quick. Do you know why industrial breakers are set up for red is a go for power and green's a no-go for power?
You have to be more specific. Industrial breakers.
Like all the ones that we like, all the, the power disconnects inside the machines. When you like, it doesn't matter who makes them, whether it's like Mitsubishi or Allen Bradley or anything like that. Whenever you got it flipped, you've got it with the power on, it shows red. And when you turn the breaker off to do any kind of work on it, it shows green.
Is that how they're built, or is that how CAT just handles?
No,
it might
that's
be
how-
standard.
That's like an actual standard because I haven't seen one that's any different than that.
I don't know. I'm thinking red is like caution warning, and green is like it's powered down. Go ahead, kind of thing.
Okay.
Just a guess, but I don't.
Well,
I don't have a good answer for you.
okay. Somebody else asked me the other day why it was like that, because we have 4 new apprentices, and I couldn't exactly explain it, but why they use that color code, because when you start out, it's kind of counterintuitive to what you're doing, because usually green means there's a go for power. It's a go for power. Red is a no-go for power, or no-go, like stoplights. But I guess not everybody goes with the same light system as the U.S. I don't know.
I don't know. But I think if you're going to get your fingers in there messing around, you better know how to use a meter anyway, not just trust the pilot lights.
Yeah, no, that's for sure. Well, they're not allowed to touch anything yet. They have to go through the whole lockout, tag out system first.
Yeah, it's fun.
They won't let them touch anything for 6 months.
Wow.
All right. That'll be, if that's all, you have a good day.
You too. Yep, tomorrow we'll go over homework and take a look at the next lab.
Okay. Why is the VFD paperwork, some of it's redacted?
What do you mean?
Like there's some of it's been like omitted from like the papers. There's a couple of them that has like eraser marks through it or something where you can't read it. On 16.
Oh, I think I know what you're talking about. Can you see my Blackboard screen?
Yes, I can.
All right, and you're talking about opening up these.
Not the actual homework, but on your Google Drive, the actual papers that you read.
Mm-hmm. 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 See how it says edited on the side?
Okay.
Secret information.
It's not really. I just want to. What? Oh.
What are you doing? Come on, man. You're confusing me.
Hang on, I'll show you.
Okay.
All right, so you're talking about.
I think it shows the inside layout of something.
Oh crap! That looks
like that.
Yeah, I just apparently, if that was me, did a really bad job of this. Or maybe this was like I just started editing it. I don't know. But if it's that, then you don't have to pay attention to that. So what that is it walks you through step by step those MT5 trainers that we have in the lab.
Okay.
But that's why those were erased. It was just telling you not to pay attention to that. But for the homework, all you need to know is like and this should be erased too. Okay, so all this stuff should be erased. But apparently I didn't get that far.
That's all right.
Let me see. Yeah, so I'd like to go through some of this stuff eventually. Yeah. I'd like to go through some of this process stuff with you guys, like programming a drive on the drive that I have mounted behind me.
Okay.
But yeah, man, all of this stuff you don't even need because it's just like, yeah, it's really just to answer the questions you need like this stuff, you know.
Okay.
The skills is what should be erased. So,
those are the older, that's an Allen Bradley, right?
Yeah.
The older ones I haven't had to program, but the new ones, the PowerFlex,
mm-hmm.
there you have to get into the parameters and put in like what type of motor, the RPM rate, and everything like that, and it kind of auto sets it up for you. It's way better.
Yeah.
I don't know.
Yeah.
Okay, I was just
Bradley's usually pretty easy to work with.
they're easy because everybody around like everybody I've ever worked with usually does the Allen Bradley drives themselves. One guy I worked with did the Toshiba, and he was one of the few guys that understood all the parameters in those better than the Allen Bradleys. And they're good. They're really good. They're easy to work with too. But you can change them really easy, the Toshiba drives, to fit anything you want. And you can actually slow the carrier signal down so you can run those on a non-inverter wound motor. So
How is that? How is that okay?
well, if you slow the carrier signal down, you're not pulsing as fast. It's not repeating that as fast. So what you're doing is you're not heating up the windings by trying to control the waveform as close. So instead of pulsing, and so if you're like it way low, like say you can actually audibly hear it pulsing at like 6,000 hertz. It's like 6,000 hertz. Instead of trying to pulse at like 12 or 20,000, it'll actually control it so you're not pulsing the windings as often and heating them up and changing the state of the winding. Like
That's interesting. But I wonder what that seems like it would have an effect on torque or horsepower, you know, if you're knocking down the signal.
So instead of having that following the waveform, you're having longer pulses. So like the first waveform might be like, to follow that, it's going to be shorter, but you know, it's going to be the square a little bit higher, and then it'll go higher and then a little bit longer and higher and a little bit longer. And then it comes back down instead of being really, really fast.
I see.
And Toshiba shows it in one of their manuals. It's interesting the way they do it. But for people that have to run older equipment like Caterpillar does a lot, those drives solve problems that Allen Bradley, because they're so proprietary, they really don't want you to know how to do that, how to change those settings sometimes. Because they don't want their product blamed for problems that for people that are ignorant of how they're really supposed to be used.
Right.
So, all right. I appreciate it. Have a great day.
You guys have a good day. Garrett, you good, man?
Yep, I'm good.
All right. Have a good day. I'll see you guys tomorrow.
See ya.